this side, and I'm presenting how does air pollution affect heart disease. So I chose this topic because I'm really interested in the medical field, and I'd like to look at the human anatomy, its structure, and see how it functions. And I also wanted to include some environmental science into my presentation because the heart isn't just a body part that functions 24/7. It's constantly affected by living things around us and how they interact with our environment. And so one of the main non-living factors that affects heart disease is air pollution. So I would like to share with you today how the heart is affected by air pollution. So how does the heart function? So the heart is like two pumps in one. The right side of the heart receives oxygen, depleted blood from the right side and through the vena cava and pumps it into the lungs. And the left side of the heart receives oxygen-rich blood from the lungs through the pulmonary veins and pumps it into the body, out into the body. So what is heart disease? Heart disease is the name for the class of diseases that affect the heart and its blood vessels. Heart disease is the leading cause of death almost everywhere around the world except for Africa. In fact, there are many types of heart diseases, and many of them involve circumstances in which the blood vessels get blocked or narrowed. So here you can see that in the heart, where the vein pressure got blocked by a plaque buildup, and that stopped the blood flow. And so that can stop the blood from the oxygen going in, the blood from the lungs going into your body, and that can cause health issues. So how does air pollution fit into all of this? So air pollution is the presence in or introduction of into the air of a substance which has harmful or poisonous effects. And the 6 main types of air pollution are ozone, particulate matter, carbon monoxide, nitrogen oxide, sulfur dioxide, and lead. And in this picture, you can see that the main sources of air pollution come from agriculture, fire, industry, sewage plants, and they can affect a lot of stuff that we use daily, like the soil we have, agricultural products, drinking water, and even the human health. And so this is another picture of how pollution is emitted into the air. So how does air pollution affect heart disease? So one pollutant in the atmosphere is called PM 2.5, and it's short for particulate matter that is smaller than 2.5 microns. And it's emitted year-round, and people are constantly breathing it in. And PM 2.5 causes damage to the cardiovascular system, the nervous system, and many more. So it gets into the lungs and vessels of humans, and it causes blockages, which can lead to blood clots that can be deadly to the heart. And another pollutant that is harmful to the human body is nitrogen oxide. And so in cities where there are high levels of nitrogen oxide, the death rate is 4 times higher than in cities with low levels of nitrogen oxide. And this is how small PM 2.5 is. So the human hair is 50 to 70 microns in diameter. Now, PM 2.5 is only 2.5 microns in diameter. So how can we control how air pollution affects our heart? So even though there isn't a specific cure for how air pollution affects our heart, there are some things that we can do to protect our heart and lower our chances of getting heart disease through air pollution. So some simple things that we can do is to stop smoking, control our blood pressure and cholesterol, we can control our weight and exercise, and we can also avoid areas with high smog levels. And one really important thing is to always look at the air quality index. It's the standards are set by the EPA, and it tells us how healthy the quality of our air is. And so this is the chart. And on a good day, the air quality is good, and that means we can go around and do activities outside. But as more and more pollutants are added into the atmosphere on certain days, the air becomes unhealthy, and very unhealthy, and then eventually it can go up to hazardous, which at one point people should avoid altogether. And so these are the sources I use. Special thanks to the professor I worked with, Professor Devan, and Helen and Myers.